Hi there, Andrew Jackson, AJ Design Studio. A while back I modelled up a exploration how to model a zip in Solidworks. I've been thinking about doing the same thing except in Rhino and using Grasshopper. So I've spent a little bit of time putting together just the basic workings. I had an idea in my head that could make something that was fairly easy to control, like the zip, where the zipper is in relation to the parameter from 0 to 1 along a curve. So I've managed to get this together. I'll just show a quick video of this animated. Okay, so this is what this bit of Grasshopper does basically. So it's splitting surfaces. It's not actually moving the CVs of the surface around. It's using pipes with a variable radius pipe to control things overall. So I'll just skip through the Grasshopper and just show you how this happens. Okay, so I've got an input layer with a surface and a curve on it, and basically if you update anything here, the Grasshopper will update Grasshopper model. Okay, so I've taken in surface and curve input, and I've projected the curve onto surface. I'll switch this stuff off. Okay, so I've projected that curve onto the surface. That's sort of like the path of the zipper. Then I've extended that curve smoothly 30 millimeters out each end. Make sure everything extends past my sort of main surface. And then I've made a variable pipe, as you can see here. So that variable pipe is controlled. There are 4 points along its length from the 0 to the 1. I've reparameterized the curve once it was extended, so it runs from 0 to 1. 4 points on that length. There is the 0 end, there is the 1, and I've got the zip position, which is basically the point I can drag, to simulate the pieces of cloth coming together. And I've got this thing called the zipper blend length, which is like where you have the actual zipper head. So this sort of simulates how long that distance is between the opening on the front and the opening on the end of the zipper. And then I've used a graph here to slow down or bias how quickly the top here pulls together, as you can see. That sort of happens last, because I don't want it pulling together right, you want it pulling together later when the zip comes towards it. Okay, what else we got here? Zip close radius, so the width basically of the zip. So it's 4 millimeters overall, that's per side. Zip open radius, which is this distance here, so when it pops out the other end of the zipper. And then up the top here, this is the widest, so if I change that, it gets wider. Yep, and then we hide that, go in and we split the main surface and intersect the variable pipe with the main surface and extend those curves out again, making sure it's on smooth. Sorry, it's a bit late here, so. And then we go on to just splitting those surfaces at the end. Hide this guy. Okay, so at the end here, create another pipe, non-variable this time, and that has the diameter, the radius of the spiral, so the actual spiral part of the zipper. And then I just split out the surfaces, list them here, and apply material. And I've called it the outer tape, like the fabric piece of the outside of the zipper that the spiral's attached to. And again, that's just another pipe that splits these other surfaces here, and I've got a radius here which sets the width. So yeah, so this is sort of like my little experiment, see if it was going to work before I actually bothered populating the actual patterns and stuff along the these placeholder surfaces. But it looks like it worked, and it looks like it updates okay. It's a little bit not too slow once you actually I'm dragging this real time. Plug in some numbers. And also it's, we get that surface and we drag some points around, seems to update okay. And you can also put a second set of inputs here. So if I disable the solver, and then we'll just change the curve and change the surface. Enable the solver again. Okay. And there, so it's updated using those other surfaces, and it seems to work alright. So yeah, just a little proof of concept. It'll be interesting to look at and interesting to share. Thanks for watching. Andrew Jackson, AJ Design Studio. See ya.